today is radicals and how to simplify, how to multiply, and how to rationalize radicals. They can mostly be done in a calculator, but it can be a little easier if you just know how to simplify them. It's a lot faster. That way you don't have to change all of your answers to decimals. It's a little bit quicker. So let's kind of talk about the parts of a radical. So here's an example. So what is the little tiny 3 called? What do we refer to that 3 as?
Is it the index?
It is the index. Oh my gosh, Asia. Holy cow. It is the, she looked it up. Did you cheat and Google it?
I swear I didn't. I just knew it.
All right, this little 3 is called the index. So the index, if it's a square root, we don't put the 2. It's just called square root. Okay? But this is referred to as the index. The 3 is called an index. What do we call the actual square root symbol? That is called the radical. Good job. So the square root symbol is the radical. Square root symbol is the radical. What do we call the information and the terms underneath the radical? This one we don't use as much. This is called a radicand. Radicand. So what's underneath, so all the terms underneath the square root is called a radicand. So we have the radical, which is the square root symbol or the root symbol. The index is the tiny number that is shown. Okay. The index is the tiny number that's shown. If it's a 2, we don't write it, then we just call it a square root. If it's a 3, we call it a cube root. Okay. And then underneath, the underneath stuff is called a radicand. It's just important to know proper terminology, so when you're reading a problem, it's not as complicated as it sounds because you actually know what the stuff means. Okay? So we're going to start with the basics. The basics are adding and subtracting and then multiplying. Okay? So when we add and subtract radicals, it is exactly like adding and subtracting variables. In order to add them properly, the radicals have to match. Okay? So what that means is, to add 2 square roots of 7 plus 3 square roots of 7 plus 10, you group them based on the root, okay? So we've got the square root of 7 and the square root of 7, making those like terms. So you could technically envision this like 2x plus 3x plus 10. So what do we get when we combine those radicals? 2 square root of 7 plus 3 square root of 7 is how many square roots of 7? 5 square roots of 7. That's it. Treat them kind of like variables. 2x plus 3x is 5x. All right, what about the 10? Can I do anything with it? Can I combine it with this? No. The plus 10 is just there. That's it. So when you're combining these radicals, you have to look for the matching pieces underneath. And then you add the outside numbers. So all we did to get those values, we added the 2 and the 3 to get 5. That's it. The underneath part, you don't add. So what you want to do is treat them kind of like variables. We don't add x's, we add the numbers in front, the coefficients. Okay? Subtracting works the exact same way. So if I have 5 square root of 5 minus 2 square root of 5, how many square roots of 5 are left? 3. 3 square roots of 5. All you're doing is paying attention to the coefficients out front, and that's how you get your answer. Nothing happens underneath, it's just the front numbers. The only time that you mess with underneath the radical is when you multiply. Okay? So adding is basically the same like adding variables. However, multiplying is a little trickier. To multiply, you multiply the outside numbers first, then you hop underneath the square root and multiply underneath. So the big number out front, so we're still going to have that square root, you start with 3 times 4. So 3 times 4 is 12. And then you multiply underneath. 2 times 3 is 6. So I'll break it up even more so we can know how we got those answers. Oops, not. That should be a F3. Sorry. So all you're doing to get these answers, when you multiply, the numbers out front, they don't have to match. They're just along for the ride. And then the numbers underneath, okay, the numbers underneath, like the 2 and the 3, you multiply them together to get 6. So when you multiply square roots, the underneath part doesn't have to be the same. You multiply outside first, then you multiply inside. Okay. So 3 square root of 2 times 4 square root of 3 is 12 square roots of 6. All right, let's do the next example. What do I get when I multiply square root of 6 times 3 square roots of 3? Yeah, 3 square root of 18. Our next little section is about simplifying radicals. Do we remember how to simplify radicals? Yeah, you build a little factor tree. Okay, we can do it that way. So let's practice. We are going to practice simplifying radicals right here. But the best, easiest way to simplify a radical is to look for perfect squares. So remember we listed those perfect squares, I think on like page 2. It's like 4, 16, and so on. 4, 9, 16, all that stuff. What is the biggest perfect square that goes into 18? No, a perfect square. So like 4 times, or 9, or 16. Okay. I found my calculator. So the way you want to do these, we know our perfect squares. Okay, I'll list them over here. We know 4 is a perfect square, 9, 16, 25, 36, 49, 64, 100. One what?
196.
Thank you.
225. 256. 289. 324. 361. 400.
What was the one after 256?
289.
So these are all perfect squares. So hopefully we can remember those. If not, you can at least remember up to 12. Okay? All you're going to do to test your perfect squares, which we will, again, practice right here. But all you're going to do to test it is you take 18 and you start just dividing it by perfect squares. So I'm going to start at 16. The way that you do this is you start at the lowest one after it. So 18, I can't use 25. It's too big. So I got to go work my way down. So 18 divided by 16, I get a decimal. Doesn't go in even. Then I jump down to 9. 18 divided by 9, I get 2. So that means I can do this. I can break up my square root. So right here, what I'm going to do is say, okay, well, what is the square root of 9? 3. So the 3 is now free from square root jail. But the 2 is not. So 3 times 3 is 9 square roots of 2. That's how you simplify a radical, which again, we're about to do it anyway. So it's okay that we did it here. If you didn't understand that, we're going to practice it again. So all you do is list out those perfect squares and you just start dividing the number inside by square roots that are lower. And then you square root them individually. So basically what we did was, okay, the 3 kind of stays here. The square root of 9 is 3. The square root of 2 is not simplified, so it just stays here. It's a lot faster than building the factor tree. You can do the factor tree, but it's going to take a little bit longer. So let's try this next one. We want to pay attention to those perfect squares. So we're going to simplify the square root of 48. What perfect square should I start at when dividing? I got to start at 36. You cannot start at square or perfect squares that are larger. So I'm not going to start at 49. Okay? As you learn your multiplication facts, as you learn those, hopefully this becomes a little easier. So 36, that's a decimal. Okay, and then I'm jumping down. Obviously 25 is not going to go into that because it doesn't end in a 5 or 0. So I can skip it. 16, I get 3. So the 16 is what I square root. The 3 stays underneath. So what happens is this breaks up into the square root of 16 times the square root of 3. We're basically unsimplifying. You know how when you multiply square roots, you multiply underneath? So I'm finding the factors. What is the square root of 16? 4. Square root of 3 is nothing. That's all you do. Okay. Having that little list of perfect squares is really easy to start simplifying. It makes your life a lot easier. All right. What about the square root of 81? 2 square roots of 81. What's the square root of 81? 9. So what's my answer here? 18. Yeah, 18. Just 2 times 9, which is 18. Just like that. Okay. All right. Now we have a cube root. A cube root of 56. So I would recommend on this one, if it's a cube root, I would build the factor tree on these because these numbers are perfect squares, so they only work with square roots, whereas perfect cubes, those are a lot more harder to memorize, okay? So what I would recommend is building the tree. If it's a cube root, notice how our index is a 3. I can't use square root stuff with cube root stuff. They're not the same. So what do I get to multiply to get 56? What times what is 56? Huh? 7 and not 9, 7 and... Oh, you said 8, I'm sorry. The mask is muffling your voice in here. All right, let's break up 8. What times what? 2 times 4. And then 2 times 2. Now, the way that you simplify a cube root, if you were going to do square roots, you would look for 2's. Cube roots, you got to match in groups of 3. Yeah, so I have 3 2's. Okay, since it's a cube root, I have to match in groups of 3. So I'm going to write my cube root symbol. That's along for the ride. What value goes out front? 2, right. We're basically cube rooting 8. So I've grouped all 3 of my 2's. So I have 1 2 that comes out. How many x's can we pull out? We got x to the 5. How do we pull out x's in a cube root? Let's break it down. X to the 5 is x times x times x times x times x. The grouping of 3 works the same. So how many groups of 3 can we pull out with x? 1 group of 3. So since I'm only pulling out 1 group, x is to the 1 power. I'm pulling 1 group of 3. Okay. What's left inside? X squared. So my 7 is here. X times x is x squared. Can I pull a y out? No, it's got to be in a group of 3, and that's to the 1st power. So this is just y. We're going to spend plenty of time simplifying and practicing. So the things about simplifying radicals is you have to look if it's square root or cubed root. If it's cubed root, I would build the factor tree and look for groups of 3. Factor tree, look for groups of 3. If it's a square root, I would just simplify using square roots. Okay, simplifying with my perfect squares. So just pay attention to the index. It's going to make it a little bit easier to follow. And we will spend plenty of time practicing. Okay, rationalizing. Rationalizing or dividing by a radical. It is not proper to have square roots in the denominator of a fraction. We just don't do that. Okay? So what that means is we have to change the way our fraction looks. Rationalizing doesn't actually change the value of the fraction. It changes the appearance of the fraction. Mathematically, it's the same value, but appearance-wise, the square root isn't there. How do I rationalize 3 over the square root of 5? Good job. So rationalizing is where you multiply the top and bottom by the square root on the bottom. Now you have basically square root of 5 over this. Oh, I wrote 3. Sorry, that should be a 5. Now basically what you have is a fraction of 1. The square root of 5 over the square root of 5 is 1. So I'm basically just multiplying this fraction by 1. It's just changing the way the fraction looks. Now, to multiply fractions, it's top times top, bottom times bottom. So 3 times the square root of 5 becomes what? Yeah, 3 square root of 5. What's the square root of 5 times the square root of 5? Square root of 25, which is what? 5. So what happens here, the part that we don't really show is this little part. When I'm multiplying these, I get the square root of 25. But the square root of 25 is just 5. The reason we're multiplying by the square root of 25 is so the fraction goes, or the square root goes away. That's the whole purpose of it. So mental math, you can do square root of 5 times square root of 5, square root of 25, which is 5. Okay. Then you're going to just look for any kind of simplification. So 3 over 5 can't be simplified, so we're just going to leave it as 3 over 5. And this is your final answer. Okay. How do we do this one? Square root of 5 halves. I don't have a square root in the top and bottom. What should I do? What's the trick? If you've got a fraction that's all underneath the square root, what can you do with the square root? This is the exact same thing as the square root of 5 over the square root of 2. So that's a little shortcut. If you have a square root and it's over one big fraction, you square root the top and you square root the bottom. So you can just shift it, break up the square root into the top and bottom. Now you can rationalize because you have a square root in the denominator, and we don't want it there. We want to change the appearance. So what square root should we multiply by? 2. You always multiply by the square root on the bottom because that's the one you don't want. Okay. What does the top become? Yeah, square root of 10. Can't simplify the square root of 10. No perfect squares go in there. 4 and 9 definitely don't go into 10. What's on the bottom? 2. Remember, the part we don't show is the little mental math part where we do square root of 2 times square root of 2 is the square root of 4. The square root of 4 is 2. If the square root doesn't go away, then there's no point to rationalize. Like, that's the whole goal of rationalizing. You didn't actually change the numeric value of the fraction, you just changed its appearance. Okay. All right, this last one. 3 square roots of 2 over the square root of 6. What square root should we simplify by? Or multiply by, sorry. Yeah, the one on the bottom. Same as before. Okay. What's the top become? We got 3 square root. Go ahead, you can finish it. Oh, it's my turn.
No, you're good. I got it.
Okay. 3 square root of 12. The bottom? 6. Yeah, just 6. Remember, the mental math that we don't show is when we multiply to get the square root of 36. It just becomes 6. We just don't show it because it's in our brain. Okay, what about the square root of 12? Can I simplify that? Yeah? What perfect square is hiding in 12? 4, so we can break this up into the square root of 4 times 3. So what does that actually become? The 3 is going to, yeah, 2.
2 square root of 3.
Yeah, you got it. So when I simplify the square root of 12, that's the same thing as the square root of 4 times the square root of 3. The square root of 4 is 2.
6.
Yep, 6 square root of 3. So I'm going to shift it down. So we have 6 square roots of 3 over 6. How can we simplify that even more?
That cancels out.
It does cancel.
Square root of 3.
Square root of 3. That's it. Okay. Okay, let's kind of take the second to review what we've done. Because simplifying radicals is a little tricky. Are we okay with adding them? Subtracting, we're good. We okay with multiplying them? Are we having any issues with the simplifying part up here? Any problem with that? The cubed one is tricky because you can't use the perfect squares. So when you can't do that, think factor tree. Factor tree, group of 3. That's the best way to remember it. We'll make it rhyme. So that's the hardest one. But are you okay with the square root ones? Okay. Any issue with the rationalizing? It does take a little bit of math. But the concept of multiplying and what we're multiplying by, we're good. I guess your Algebra 2 teachers taught you more. Okay. We'll do conjugates last. Okay. I'm going to mentally prepare for conjugates. So conjugates are a little trickier. So I'm going to turn this page over. Page 6. Conjugates, they are different from rationalizing because conjugates have pluses and minuses in the bottom. So you can't just multiply by the square root. That's not a thing anymore. If you just have a square root in the bottom, you can rationalize. If not, you have to do what's called multiplying by a conjugate. Okay? And this was taught in Algebra 2. You might not have liked it then. You still might not like it, but that's okay. So the way that you multiply by a conjugate, the square root has to be in the bottom. Then I'm going to look at the denominator, which is x plus the square root of 3. To multiply by a conjugate, you multiply by the opposite. So this looks like x plus 3. I'm going to multiply by x minus the square root of 3. These signs must always be different. What we're basically doing is creating a difference of squares on the bottom. So remember when we did factoring with the difference of squares, you had like x minus 4, x plus 4 in parentheses. Same idea here. It's basically the difference of squares. Okay. Now what you're going to do is distribute. So the thing you have to know is you always want the opposite of what this looks like. So if this is plus, you always put minus, or vice versa. Next, you distribute. So in the top, I'm going to have 4 times x minus the square root of 3. I'm multiplying top to top. The bottom is the difference of squares. So do we need to go back into the difference of squares and like what it looked like to begin with factoring real quick? We know what difference of squares is. X plus a number, x minus a number. What we're basically doing in this stage of conjugates is we are taking, so I'm going to just put it here. We're taking basically this difference of squares and we're going to put it back to where it came from, what it looked like. Okay, so the concept is very similar. It's going to look a little weird. So for the bottom, what is x times x? X squared. Okay. Since it's a difference of squares, what sign should be in the bottom? Difference of squares. Yeah, should always be subtract. What's the square root of 3 times the square root of 3? What's the square root of 9? Which is 3. So I'm going to write just 3 here. That's all you do. You could, if you really, really wanted to, just with all your heart, you really wanted to distribute all that out, totally fine. The middle term, though, the x value, it's going to go away. Because right here, when you have x times negative square root of 3 and then x times positive square root of 3, they're going to cancel. So it's basically the difference of squares. If you were to do the difference of squares here, you would take the square root of x squared, x and x, the square root of 3, which would be square root of 3, square root of 3, plus minus. And then at the top, you can just distribute. So 4x minus 4 root of 3 over x squared minus 3. And you're done. If you remember that it's the difference of squares on the bottom, this becomes a lot easier.
I feel like I'll forget when it's already simplified. I would leave it.
When to simplify this?
Like, yeah, so like if I just left that like that, but say it needed to be simplified again, so like I would know.
The only simplified that it could be is if this square root could be simplified. But other than that, there's nothing else you can do. There's no GCF. If you factor the bottom, you just end up where you started. So basically, what is happening in the bottom is you do x times x, which is x squared, and then you multiply square root of 3 times square root of 3, which is just 3. And then the middle is always negative. Like, that's how you get the bottom. You're basically undifference of squaring. Right? And that's called multiplying by a conjugate. Now, that's with just x. We're going to practice with some numbers. It can get a little complicated, especially when it comes to simplifying. Right? I'm doing lots of algebra 2 today. All right. What should I multiply on this one? Yes, 3 plus the square root of 3. Remember, it's the opposite of what you start with. You start with minus, change to plus. Okay, I'm going to do that on the top and on the bottom. Okay. So on the top, we're distributing. So you have 2 square root of 2 times 3. What is 2 square root of 2 times 3? Two root 2 times 3. How do we multiply these? Yeah, 6 square root of 2. Then we do 2 square root of 2 times the square root of 3, which is going to give me what? So 2 square root of 2 times the square root of 3. Can the 2 multiply to anything, this outside one? Good. 2 square root of 6. We're just distributing. If you want to write it out like we did right here, you can. If you want to do 2 square root of 2 times 3 in parentheses and then simplify, that's fine too. But all we're doing is distributing. We're doing this.
Can you not go ahead and do them?
That's all we're doing. What? Okay. What does the bottom become? So let's look back up at that top problem. How did we get x squared?
Big 9 plus 3.
Good. But it's not going to be plus.
Minus.
Yep. So it's going to be 9 minus 3. What happens? Remember what happens. This part right here is basically just 3 squared, which is 9. 3 times 3. That's how you got this term. Then you have the square root of 3 times the square root of 3, which is the square root of 9. The square root of 9 is 3. That's how we get this term. Okay. This is the only time it's okay to do that shortcut because it's the difference of squares. And then it's... Huh?
You should go over the top.
Yeah, this part right here?
Yeah.
Okay, so all we did on the top part is we just multiplied the 2 square root of 2 and distributed in. So we did 2 square root of 2 times 3. So we just have like this problem. 2 times 3 is 6. The square root of 2 has nothing to multiply, so it's just the square root of 2.
Okay.
So let me post it. So basically, what this is, it's like 2 square root of 2 times 3. The only thing we can do is 3 times 2, which is 6. The square root of 2 is just along for the ride.
Okay.
Then to get this term, you do the same thing. So plus 2 square root of 2 times the square root of 3. Well, the 2 has nothing to multiply by, but the square root of 2 times square root of 3 is the square root of 6. So that's where those terms are coming from. You're just distributing. Mm-hmm. So it's basically exactly like what we did on the front page, only now it's in a fraction. But mathematically, same thing. Multiply the coefficients or multiply underneath. Okay. Now we need to simplify. Can I simplify the square root of 2 or the square root of 6?
Oh, yeah, that's what it
What's the perfect square though?
Oh,
No, you can't.
No, 4 is the only one that could go into 6 and it doesn't go evenly. And then 2, there's nothing below 2. So those are good. So I'm going to leave these as 6 square root of 2 plus 2 square root of 6. What's the bottom become? 6.
And then you cancel out the ones.
We can cancel out the 6s. However, don't cross it out yet because I saw this on your factoring quiz. Some of you tried to simplify the quadratic formula, but you only tried to simplify part of it. When you simplify fractions and you have a plus or minus in the top, you have to pull out a value from each term. So 6 is not my GCF. What is the GCF here? Looking at 6, 2, and 6. What can I pull out at the top? I got 6 and 2. What's my GCF? Because we can cancel stuff, but we can't cancel yet.
2.
Yes, good, 2. So if I pull a 2 out, what's this first square root look like? If I pull a 2 out, what's 6 divided by 2? 3.
3. Square root of 2.
Good.
And square root of 6 all over 3.
Yes. Well, all over 6. We're going to leave it as 6 because we're going to cancel. So all we did was we pulled out a GCF. Okay, we pulled out a GCF of our values. Okay, we pulled out a GCF of 2. Pull that over. This takes a little bit of time, but mathematically, we're not doing anything radically complicated. It just looks, yeah. It's just simplifying. Like 6 and 2, the GCF is 2. That's all we're doing. If it confuses you, think of the square roots as variables. Like 6x plus 2y. I can pull a 2 out. That's it. Now I have 2 and 6. How do those cancel? What am I left with the 2 over 6? Yeah, 1/3. So the 1's going to go away, and I'm just left with 3 square roots of 2 plus the square root of 6 over 3. Now you cannot cancel those 3's. I know you want to so bad because you see 2 3's, they're out of square roots, but remember with fractions, simplifying fractions is different. It has to be in every single term.
Can you still keep the one if you want to?
Yeah.
And just put it in still put parentheses?
You can put 1 parenthesis 3 square root of 2 plus 6 if you want to. If it just makes you happy. Totally fine. You could, like right here, how 2 over 6 simplifies to 1/3 if she wants to leave it like this. Like with the 1 out there. You can. But you don't have to because you don't need it. So I won't write it like that, but if you do, I'm never going to count it wrong. It's not wrong. You just don't have to write it. And that's the answer. I know that seems like it took us like hours to do. All right, it's been a while since you've had algebra 2. Okay, let's try the next one. The next one is going to take just a little bit more time. It's nothing that we can't do. It takes a little more math. All right. Let's try this next one. What should we do here?
2 square root of 6 minus 3.
Good. 2 square root of 6 minus 3. On the top and on the bottom. Okay. All right. Let's simplify the top. Let's take it a step at a time. So we need to distribute. I'm going to do 2 square root of 3 times 2 square root of 6. We'll start there first. We're just distributing. What does that become? 4.
18.
There we go. 4 square root of 18. And we'll simplify later, but yes, it can simplify. We will get to that in a minute. Then we're going to distribute again.
Minus 6 square root.
Yes. All we're doing is basic multiplying. Okay? Just like what we did on the first page, only it's a fraction. Where it gets tricky is just the bottom. The bottom is the trickiest part. Okay? We're going to do the exact same thing as we did up above. All you do is square them. So right here, for the first term, we're going to have 2 square root of 6 times 2 square root of 6. This is going to become 2 square root of 6 squared. It's exactly like up above how we had 3 squared, only now we have another square root. Okay. Remember your exponent properties. This can become 2 squared times the square root of 6 squared. We're just squaring, that's it. Distributing my square down. Okay, what's 2 squared? 4.
Square root of 32.
Well, okay, the square root of 36 is what? 6. 4 times 6 is? 24. Which goes here. Have I lost you at all? All I did was 2 square root of 6 squared. You're going to do the same thing for 3. Okay. Same idea. I've got 3 times 3, which is 3 squared, which is 9. What term goes here? Minus always. It's always minus. And we're just taking it nice and slow. It's complicated. There's lots of easy ways to mess this up. Very easy ways. All right. Let's start looking for simplification. We got 4 square root of 18. Can I simplify the square root of 18? Is there a perfect square hiding in 18?
Yes.
What is it?
Well, you can break it down to 4 and 3, which is 2 and 2. So you bring out 2 and leave 3 in the square.
Wait, for 18?
Oh no, not like a perfect square. I thought you were just breaking it down.
Well, there is a perfect square that does go into 18. What is it?
6.
6 isn't a perfect square. 9 is a perfect square. Remember, when we say goes into, it means when we divide, it goes in evenly. So what we would do is to test, okay, again, if we're unsure,
I didn't mean 4 and 3.
that's okay. All you're going to do is go down that list. So the first list that we wrote on page 5, the biggest square root that is less than 18 is 16. So I would just do 18 divided by 16. I get a decimal, so 16 is not my perfect square. 18 divided by the next one is 9. I get 2. The square root of 9, that's my perfect square I want to look for. So this should break up into the square root of 9 times the square root of 2. Okay. So square root of 18 becomes the square root of 9 times the square root of 2. I'm just simplifying above it to make my life a little easier. What is the square root of 9? 3. Square root of 2. So what I'm left with is 4 times 3 square root 2. And if you want to go ahead and multiply those to get 12, you can. But for your notes, I'm just putting it that way so it makes a little more sense. Can I simplify the square root of 3? No. So 6 square roots of 3. What does the bottom become?
Yes,
15. 24 minus 9 is 15. Okay. Let's continue to simplify. 4 times 3 is 8.
It's 12.
Oh, it is. There we go. All right. Now, once we've simplified all our square roots, there's nothing else we can do. Is there a GCF we can pull out of the top that could cancel with part of 15? 3 is the GCF. Okay, so if I'm going to pull a 3 out, let's just divide everything by 3. So 12 divided by 3, 4 square roots of 2. 6 divided by 3, 2 square roots of 3. On the bottom, 5. And that's it. When you simplify square roots and you simplify fractions, it is very, very important that you simplify everything. Every piece of the problem has to pull out. I can't just simplify the 12 and 15. It has to come out of 12, 6, and 15. Okay. Let's do one more like the top. It seems like it's taking forever because we're going through the process. Once you know how to do it, it's not going to take this long. For the ACT, it can't take this long. All right. If they're going to put anything on the ACT, it would mostly look like this one. And if worse comes to worse, you can always use your calculator, but I want to make sure you know how to do it in case your calculator dies. All right, this one is the last one we'll do before we do some practice. So what should I multiply here? Yes, I'm going to change it to plus. So I get 3 square root of 6 plus 7. Okay. 3 square root of 6 plus 7. This problem is going to take a little bit more time just because we have to distribute a little bit more. Mathematically, it's not a harder problem. It's just a slightly longer problem. All right, so to distribute on the top, I'll change that to there we go. A little bit of space. There we go. All right, so you're going to do 3 square root of 2 times 3 square root of 6. What does that become?
9 square root of 12.
Good, 9 square root of 12. Then I'm going to
Can you
continue.
just go ahead and combine like terms, then do it?
Oh, that is a great idea. Yeah, let's do that. Yeah, we can do it that way.
Same base.
So let's combine the like terms. I like that idea. Good looking out. I was going to make you do it the long way. All right, so let's combine the top.
That's 6 square root of 2. Or 4.
We're adding them first. So 3 square root of 2 plus 2 square root of 2 is 5 square root of 2. So let's go ahead and just do 5 square root of 2. And then we'll leave this part in parentheses. 3 root 6 plus 7. Then we'll distribute. Good looking out. Smart. Definitely save us plenty of time. So all we did was we added the top. We're multiplying. Okay. So on the bottom, let's simplify the bottom. So we've got 3 square root of 6 times 3 square root of 6, which is 3 square roots of 6 squared. Remember, to simplify, we distribute the square. So this becomes 3 squared times the square root of 6 squared. Yes, it is 54. Good job. So we get 9 times 6, which is 54. What's the next term?
-7.
Yeah, so we got 7 squared, which is 49. And then remember, we always subtract in the middle. So you can simplify it and then put it up, or you can simplify as you go, whatever is easier for you. Okay, now let's distribute a little more. So 5 square root of 12 times 3 square root of 6.
5 square root of 2.
What did I say wrong?
Yeah, you said 5 square root
Oh, sorry, I was multiplying ahead. So 5 square root of 2 times 3 square root of 6. What does that become? 15. Good, square root of 12. Continue the distributing. 5 square root of 2 times 7. 35 square root of 2. Over, let's simplify the bottom.
And since 5 is 5. 54 minus 49 is 5.
Mm-hmm.
So then can you not say that 5 measure?
You want to pull the 5 out?
Yeah.
Okay, let's do that. So if we pull a 5 out, 5 divided by, or 15 divided by 5 is 3 square root of 12 plus 7 square root of 2 over 1, but we don't need the 1. Okay. Can I simplify anything else?
Is it square root of 4? Because 4 is in 12.
Yes. So let's break up the square root of 12. It's the square root of 4 times 3. So it's the square root of 4. Good. So 2 root 3 plus 7 root 2. So if we're continuing to simplify, what's our last piece? What's 3 times 2?
6.
Yeah. 6 square root of 3 plus 7 square root of 2. Okay. Conjugates are a pain. I totally feel you. We're going to practice them, but not as much as we practice how to simplify square roots. On the ACT, you may have one like that, but you will have a lot where you have to simplify square roots. So I want to make sure that we can practice how to do this, but the focus is going to be adding, subtracting, and simplifying. And rationalizing. Those are the main components. But I want to make sure that we have seen this before, so you're not like, what in the world? So what we're going to do is practice for the next 15 or so minutes, and then we'll continue it tomorrow.